Hello, everybody, and welcome to the very first part of Unit 5. Unit 5 is going to be covering cognition. Now, cognition will be broken into two main pieces. The first piece is going to focus on memory and problem solving. The second part is going to focus on testing and what is called individual differences, which has to do with intelligence. They are very much connected, but we're going to split them into two just so we can kind of tear them apart a little bit more. So we're going to start today by just kind of laying out a little bit of the basics of just what is cognition, and then we'll get into our main focus today, which will be the models of memory. Let me move myself out of the way here. So the first thing we have to talk about is cognition in general. Now, cognition is a really, really broad field of study, and it has to do with basically all of the processes of the brain. Now, it's not necessarily the biological side, it's more about the information. Okay, so whenever we're talking about cognition, we're talking about whatever kind of information processing or information is being manipulated or held or used or stored in our brain. So cognitive psychologists can be looking at things like thinking, knowing, remembering, communicating, being creative, problem solving, speaking. There's a huge kind of variety of things that are going to be going on. Now, you're going to notice in here that, again, that we're not really going to be talking about what is happening biologically, even though there's a biological basis for all of this stuff. We're really going to be focusing on the actual information itself. Okay, so how do we remember? How do we store information? What is IQ, for example? All those things are going to be part of cognition. Now, like I mentioned, we're going to be focusing first on memory. So memory, and the way we're going to define it in psychology, is learning that has persisted over time. Okay, it's information that has been stored and can be retrieved. So again, we've already talked about learning. We talked about how basically we've learned to associate things. Basically, memory is just learning that we've kept a hold of. Now, how long that is depends. Okay, we can remember something for a short amount of time. We can remember something for our entire lives. It's still considered memory. Now, memory is super, super, super important for psychology and super important for us because really memory is who we are. And you can kind of think about it this way. If for some reason you lost all of your memories, would you still be you? Right? If you didn't know your name, if you didn't know anybody that you'd ever met before, if you didn't know any of the things that you've done, would you still be the same person? So in a lot of ways, when we look at that, we say, memory is really the key to who we are as individuals. And because of that, obviously, it's very, very important. So like I said, the first thing we're going to be talking about today is the models of memory. So how can we think about memory? How can we look at it and try and kind of study it? Again, this isn't something that's physical necessarily, so we can't really look at it physically. We have to kind of look at it through different models of how we think things are going on or how we think information is being processed. So our first example is going to be what is called the information processing model. Now, there's going to be three models that we talk about. There is overlap between them. And I think that's very important to understand, is that all of these models can kind of be functioning at the same time. Okay, and they can all kind of be working simultaneously. It's just different ways of kind of looking at things. So like I said, our first model is what is called the information processing model. We've kind of talked about this a little bit. Basically what it is a model of memory that compares our mind to a computer. So if you think about how does a computer work as far as memory, how does it store stuff, how does it get stuff into it, how does it pull stuff out, that is how we're going to think about the mind. Right, that our brain is functioning the same way a computer would. Now, information processing model is going to have three stages that memory goes through, that information goes to. The first stage is going to be encoding, the second stage is going to be storage, and the third stage is going to be retrieval. Now, again, we're going to connect these to a computer, or the way a computer does something, and we're going to kind of connect that to how we think about our minds doing the same thing. So the first step here is encoding. All right. Now, encoding is the process of putting information into the memory. So taking information out of our world. So right now, all of you are encoding the information that I am speaking and encoding the information that's on our slides here. That's the encoding part. You're taking information from the world and you are bringing it into your memory system. Really simply put, it's getting the information into your brain. Now, obviously the way this happens is through our senses. So we're going to have sensory receptors that are going to, send impulses, just like we talked about in the sensation perception unit, that are going to send, right, those impulses that are, again, registered by different neurons in the brain, and that's all going to be our encoding. Now, I like to think of it, if we want to kind of think about this analogy of a computer, the encoding is basically like the keyboard on your computer, right? When you type on your keyboard, information is put into the computer, right? It is encoded in. Getting information from you through your keyboard, through your mouse, into that computer. Now, technically, there are different ways that things can be encoded, and we're going to talk about that in just a little bit. But one thing that's important is to think about how we actually do this. Now, we have sequential processing, and we have what's called parallel processing. Now, as humans, right, our brain is always going to be doing that parallel processing. We're going to be doing multiple things at once. When we are listening or trying to learn or read or carrying out some activity or playing a game or whatever, our brain is doing a whole bunch of different activities at once. And you can see that kind of in that image at the bottom there, where it's taking in information from different pieces at different times, it's melding it together, it's running multiple things at one time, where a computer is always a sequential process. So computers are always going step by step by step by step, and they go in that step, they just go incredibly quickly. Okay, so there is a little bit of a difference in how that's actually happening. We've talked about parallel processing before already, but it's just kind of important to remind us of how that is functioning a little bit differently. So the next piece we're going to look at is ways that we can kind of break up encoding and different ways that we can encode. So you kind of want to think of this not kind of within encoding, right? I don't know how you want to do that in your notes, but think of it as stuff that's going within this section of encoding in this first step in this process. So the first thing we can do is break up encoding into effortful and automatic processing. Okay, effortful and automatic. Effortful processing is processing that takes attention and effort. So it's something that we consciously have to focus on, consciously have to look at, consciously have to try to remember. Really simple example is what we are learning right now. Right now, you wouldn't be pulling in any of this information if you weren't consciously focusing on it and paying attention to it. And you guys know that, right? When you're in a class and you're not paying attention, you don't remember any of the stuff that you learned that day. So effortful processing, it requires attention, it requires conscious effort. Now, effortful processing creates what are called explicit memories. We're going to talk a little bit more about those in just a bit. But it creates explicit memories. Explicit memories are facts and experiences that we consciously know. So we're able to consciously go back and pull that piece of information out and remember it. Now again, this can be really basic things like facts, how to do mathematics, how to read or write, all those kind of things. It can also be experiences. So memories in your past are generally explicit memories. It's something, again, that you can pull out and you can consciously picture it and remember it at what happened. Now, one thing that is important to remember is that effortful processing can eventually become automatic. Now, generally what happens is this requires an extended period of time and it requires a extended practice. The biggest example of this is reading. And you can kind of think about this if you've been around a young kid who's just learning how to read. When they're learning, it's kind of slow. They have to, go letter by letter by letter and sound out a word, and then they get one word, and then they move on to the next one, right? Over time, it slowly gets a little bit easier where, it's not letter by letter, but maybe it's word by word, and they have to kind of put words together slowly. Eventually, right, you get to the point where you're just able to read and you don't even really think about it. And that's probably where most of you are at now, right? You look at words and you just read them, and it's kind of just it's just automatic, right? Effortless is what I want to say. It's automatic, right? You just kind of read it without even thinking about it. Again, that's just an example of how something that is effortful can eventually become automatic when it comes to processing. The same thing goes for like basic skills or like playing an instrument or athletics. We can see that same shift. Now, we can also break explicit memory into two different sections. So again, we're kind of slowly breaking these pieces down more and more. Explicit memories can be broken into first episodic memories, and I actually kind of forgot for a second there, and next semantic memories, right? Kind of blanked for a second there. So our episodic memories are memories that usually have some sort of context around them. And generally, they're going to focus on specific moments or specific events in our lives. And this is why they call them episodic. It's really easy to actually kind of think about them as episodes in like a TV show. So for example, if you watch really any TV show at all, what you'll notice is there's short chunks that are taken out, right? So for example, there might be a scene where there's a character like sitting in their living room and another character walks in and they have a conversation. Now that conversation might only last like 2 or 3 minutes, and then it ends, the scene cuts, and we go to something else. That's very similar to how our episodic memory works. You don't remember unless you have a very, very special mind, and we'll kind of talk about people like that a little bit later. But for the most part, we don't remember a whole day. You remember specific pieces that happened. And as time goes on, you remember the ones that are really important, and you kind of throw out the ones, the moments that you don't really need to remember. Which is why if I asked you, what did you have for lunch 3 weeks ago, you probably can't tell me. But if I asked you, what was the, proudest moment of your life, you can immediately kind of pull that memory up, and you can think of that moment, that short kind of chunk of time. Now, episodic memories, again, are going to have a lot of information in them. They're going to have kind of the basic factual information, like the who, what, when, where, and why and maybe not necessarily why, but I guess the who, what, when, and where of what happened, of the event. In addition, it's also going to kind of hold on to a lot of times these sensations and the emotions that have been associated with the event. So for example, if something really good happened, when you remember that memory, you probably feel the emotions. It makes you feel good. It makes you feel happy. When you remember something that was maybe kind of sad or disappointing, right, you might feel sad. So those emotions are also kind of held within that episodic memory. Another way to think of these is as our autobiographical memory. So it's the memory of, your own life. Again, just thinking about episodic. So again, these kind of small chunks or episodes of our life. In addition, we have semantic memory. Now again, right, we've got effortful processing. Within that, we have our episodic memory and our explicit memory. Okay? Now, we have our explicit memory. Within that, we have episodic and semantic memory. So our semantic memory has to do with impersonal things, impersonal memories. Now, what this is generally referring to is something like factual information or abstract knowledge, right? So if I asked you, for example, who was the, let's say, 44th president of the United States, that would be a semantic memory, okay? There's probably not a specific, event that you're remembering here. It's just a piece of information. It's a fact, okay? Again, this is the type of information that we're generally going to learn in something like a book, or we're going to learn from school, right? A lot of what you are actually studying in school, right, what you're taking time and studying is going to be this kind of information, semantic memory, right? Places, things, events, concepts are also in there. So something like the concept of economics or the concept of love, right? These are semantics, right? They have semantic, part of our semantic memory. Again, this is the kind of memory, and this is kind of the last piece here, right? This is the kind of memory that you are going to use when you're taking a test. So you're trying to pull out factual, abstract pieces of information. So again, just to kind of think about how this is all broken down, right? Within encoding, we've got automatic and effortful. We haven't talked about automatic yet. Automatic is also known as explicit. It really creates explicit memories. So this is a type of processing or a type of encoding that creates explicit memories. Explicit memories can be broken down into episodic memories and semantic memories. Okay, so you can kind of think about this kind of like a breaking this concept down into smaller and smaller chunks, or more and more specific chunks. Now, in addition, we also have automatic processing, right? So we're kind of moving back upwards a little bit here. So our automatic processing is basically what it sounds like. It's the information that we effortlessly process when we don't even think about it. It's happening unconsciously. Now, some of the biggest examples of this are things like space, time, and frequency. So, for example, when you are working on something, or you're busy or whatever, even when time kind of like speeds up or slows down, we still have this concept of time, right? You have this kind of thing that's constantly keeping track of it. And it's not like you have to consciously focus on how much time has gone by. It's kind of just a natural thing that you feel. That's an example of automatic processing. Our mind is automatically keeping track of this. It's automatically pulling in a certain amount of information. Same thing has to do with space. So we talked about cognitive maps in our learning unit. So for example, when we walk around an area, even if we're not consciously thinking about trying to remember where we are, we have kind of a natural idea of kind of this natural map that we build in our head. Again, we're doing it though without consciously focusing on it. And then the last one was frequency. So this, for example, is like if something speeds up or slows down. Even again, if I'm like reading a book and I hear a noise, in the background, I'm not really paying attention to it, but that noise speeds up, I'm going to notice that, right? Because my brain is automatically paying attention to this frequency that's changing. Now, again, automatic processes produce what are called implicit memories. So effortful creates explicit, automatic creates implicit. So effortful, explicit is usually the easiest way to remember, then automatic, implicit. Implicit memories are things like learned skills or classical conditioned association. So we mentioned before in that learning unit how classical conditioning is often unconscious. It's something that we don't consciously know we've connected. Again, that's because it's happening right through this automatic processing. It's creating an implicit memory that is separate from conscious recollection. So this are things that we can't pinpoint it, right? It's something that's just kind of naturally happening on its own. Now it's going to take us into our second step, right? So again, all of that was part of encoding, which is that first step of how do we get the information into our head. Now, the next thing that has to happen is storage. The second step is storage. Storage is very simple. It's exactly what it sounds like. Once we create a piece of information, once we pull it into our brain, we have to create a record of that piece of information. We have to hold on to it. Now, like I mentioned before, this storage can be for incredibly different lengths of time. It can be for, a few seconds, or it can be for our entire life. So storage is a lot of kind of little things that are going on, but again, it's just once that information has been brought in, holding on to it, keeping it in our minds. The last piece there, or the last step, the last step of our information processing model is what is called retrieval. Now, there are different types of retrieval. We will talk about them a little bit later when we're talking more about, how to improve memory or problems with memory a little bit later. But in general, we're focusing on retrieval, right? The two types that we're going to focus on later are recall and recognition, but we'll get into those a little bit later on. So retrieval is our ability to go back, find an old piece of information, and pull it into our consciousness, right? So finding a piece of stored information and pulling it up when we need it. It's remembering. Retrieval is remembering something. So again, if you think about these three steps, right, we're encoding a piece of information, we're putting it into our brain, then we have to store it, hold on to it, and then eventually we need to go back and get it, retrieve it, and pull it to our consciousness so we can use it. Now again, there are multiple kind of things that are happening with retrieval. For one, that piece of information needs to be located. Now, it's not like a file, it's not like a filing cabinet that there's literally neurons searching in your brain for a specific thought or whatever. But it needs to be located, and then it needs to be basically pulled up and brought into consciousness for us to remember it. So this is why, you can have something that right? I'm sure you've all had moments where you're like, I know the answer to this question, but you just can't get it, right? You just can't quite pull it out. That's basically a problem in the retrieval. So even though the information is there, it's been stored and it's been stored correctly, we're unable to retrieve it. We'll talk more about that a little bit later, like I said, but that's this process that's going on. And then again, we can mention how different things will have different kind of availabilities to our retrieval. So some things are super, super easy to retrieve. So for example, your name. When someone asks you your name, it's pretty much instantaneous. You know what your name is, and it's not hard to kind of come up with. Other things take time, right? So again, like before I asked you guys, who is the 43rd president of the United States? That's something that you're probably going to have to think about a little bit, right? You probably have to start, okay, we're at 45, and then I got to count backwards to figure out who 43 is. Okay, so that's kind of this process that would be going on there. Now that's going to take us into our second model here. So we finished up this information processing model, which was the 3 stages, right? Encoding, storing, and retrieval. We also have, our next model is what is called the level processing model. Now, the full name is technically the Fergus Crank, I believe it's Craik Robert Lockhart's level of processing model. Again, usually it's just going to be referred to as the levels of processing model. Now, levels of processing model is going to look a little bit differently. Basically, what it's going to say is how long and how well we remember something depends entirely on how deeply we process the information. Okay, so when something is being encoded, or how are we encoding it? How deeply are we processing that information? Now, they're not going to specifically make any distinctions between short-term versus long-term. They're saying it's all about depth. So if we process something in a very shallow way, we're not going to remember it for very long. If we process something in a very deep way, we're going to remember it for a long period of time. You can see an example of this model right here on your right. So there's shallow processing. Sometimes there's intermediate processing. This kind of varies. So some people will just say there's shallow or deep. Other times they'll break it up into 3 and say shallow, intermediate, and deep. But again, they're all a little bit different here. So we broke this up, and the textbook that I used broke it up only into 2 pieces, either shallow or deep. So shallow processing is the basic level of processing something. Now, generally, this is going to refer to the appearance of whatever it is. So for example, if we were talking about a word, right, and you were only processing it in a shallow way, it would be what the word physically looked like. So were there capital letters in the word? What did the letters look like, right? If you just kind of see a word and picture it in your mind, that would be this shallow processing, which is structural. Okay, again, structural, we're encoding the physical qualities of whatever it is. Now, sometimes phonemic will also be included in shallow. Sometimes people take phonemic and put it into the intermediate level of processing, intermediate processing. But phonemic is all about encoding through sound. So now instead of just trying to remember what does that word look like, I could try and remember what does that word sound like. What does it sound like? So I could think about, does it rhyme with something? I could say it in my head, right? That would be phonemic processing. What is the sound of the word? Now, again, one of the things that's really important is that shallow processing does not last very long. And the reason for that is that when we are using shallow processing, we are not assigning relevance to that piece of information. Okay, there's nothing relevant about it. It just looks like this, or it sounds like this. Now, we can contrast that with deep processing. So deep processing is where we are attaching some sort of meaning to a piece of information. So I hear a new word and I attach meaning to it. Now, one of the best ways to do this is by creating associations between that new memory or that new piece of information and an existing memory. This is why when I have you guys do your notes, one of the things I try to encourage you guys to do is, in that column is add examples from your own life. where every time a word comes up, if you can connect it to something that actually happened to you or something you experienced, the same thing with our daily psychology, right? That little board that you guys can post on. What you're actually doing is you're connecting a new piece of information to an old memory, something you already know. And what's going to happen is when you make that connection, it makes it more likely that we'll remember this new piece of information. Okay, I've attached a meaning to it. Now it's not just a word. It doesn't just sound this way or look this way, but it has a deeper meaning to it. And then I'm obviously adding even more meaning to it when I can think of an example. Now, most information that we are going to remember for a long period of time is going through what is called semantic encoding. Okay, semantic encoding, or it's being semantically encoded, is how it says it on the slide. And what this means is it goes through meaning-based encoding. So all that means is basically exactly what it sounds like, where when I hear that word, I'm not just, writing it down without thinking what it is. I'm not just, looking at it and copying it. I'm consciously connecting it to meaning. What does that mean on its own? And again, this is how we're going to remember things for long periods of time. Kind of connecting it back to our notes and how we do those, hopefully, in this class. Now, we're getting to our final model here. Now, our final model is what is called the three-stage model. So we have information processing model. We have the, now I'm like completely blanking, levels of processing model, sorry. Information processing, levels of processing. And our final is the three-stage model. Now, technically, the long name that you may or may not say every once in a while is the Atkinson-Shiffrin three-stage model of memory. Again, if you remember three-stage model of memory, you'll be fine. Now, basically the way this model works is it says that there are three different memory systems that are all separated basically based on time. They're characterized by the time frame that's going on. So those three memory systems are the sensory memory, the short-term memory, and the long-term memory. Now, this chart that's on screen right now is really, really helpful. I actually do kind of suggest, even if you want to pause me for just a moment and just kind of copy it down, it's really nice to have this kind of image to look at. This is what's happening. I'm going to run through it and I'll kind of like talk about each part more specifically, in just a moment. But at the end, maybe we'll come back and kind of look at it one more time. The basic idea is information comes in from the outside world. That's our environmental input. You can see that here, right? And it goes through these sensory inputs. This is our senses. Think about sensation perception. This is what we talked about right here, sensory input. Now, when information comes in, it goes to our brain and it goes to what is called the sensory memory. From our sensory memory, it can either basically immediately be forgotten very, very quickly, or we can give it attention. Now, we talked a lot about selective attention and attention during our sensation perception unit. This is basically what we're talking about right here. So once we give sensory information or sensory memory attention, right, whatever pieces we give attention to, are going to move to the short-term memory. Now, while it's in the short-term memory, this is generally the conscious part of our memory. So this is what we're actively thinking about. We can obviously either forget something, or we can use what's called rehearsal, which we'll talk about a little bit later, but it's basically a way to try and remember something to maintain that information in our short-term memory. So we've got something we're thinking about. It sticks in our brain for a little while. We can use different things to kind of try and maintain it and make it last longer. If we do a really good job of this, or we go through what is called elaborate rehearsal, which is basically, doing a lot of things to try and remember something, we can move that piece of information into our long-term memory. Now, from our long-term memory, it can sit there. Eventually, it can be forgotten, or it can be pulled back through what is called retrieval. Kind of mentioned that earlier a little bit. And it can be put back into our short-term memory, our conscious memory. Okay, so that's the basic process that the three-stage model is based off of. Now let's talk about each of these different pieces a little more specifically. So our first one, again, is sensory memory. Sensory memory is external information, external events from our senses. So just like we talked about sensation perception, when light beams hit our eyes, when sound waves hit our ears, when pressure touches our skin, right? Information is sent to the brain. Now, our sensory memory is basically holding information for just tiny, tiny, tiny periods of time, just long enough for us to perceive them. Now, this perception is a really important part again, right? Because if we don't pay attention to it, it just goes away, right? Again, we mentioned in sensation perception that we're technically processing, 10 million pieces of information every second. So obviously the vast, vast, vast majority of that is just kind of getting dumped in the trash, and we're holding on to a few very specific little pieces. Again, this goes through exactly what I'm talking about. Selective attention, our awareness, is going to determine what fraction of that will then be encoded and taken into the short-term memory. So even though, and a nice example of this is like maybe when someone's talking to you, sometimes you know that they're like what they're saying is hitting your eardrums, but you're not like consciously listening to it. That's what's going on. Is again, you're just not paying attention to it, so it's not getting into our short-term memory. Now we can break our sensory memory into 3 different categories. Technically, we could probably break it into more, but these are the 3 main ones that you might be asked about. The first one is what is called iconic memory. Iconic memory is about our visual information. Okay, it's something we're seeing. Now, our iconic memory does not last very long. It actually only lasts for about a little bit less than a second. So for less than a second, we hold on to information that we get from our eyeballs. After that half a second, if we don't pay attention to it, boom, it's gone, thrown in the trash. We also have our echoic memory. Now, our echoic memory is focusing on auditory information, the auditory system, so what we hear. Now, our echoic memory is actually very, very good. We can hold a lot of information for about 3 to 4 seconds. Now, this actually makes a lot of sense if you think about speaking. When someone talks to you, and even as I'm talking to you right now, the beginning of my sentence might be, a long way away from the end of my sentence. So echoic memory is really important because I need to be able to remember not just one word at a time, but I need to remember, whole phrases and whole sentences that are being spoken to me. Another way that we can see this, I actually kind of gave you an example of. One place that we can see this echoic memory and how long it lasts is where when someone's talking to you, maybe it's a parent, maybe it's a teacher, and they're talking to you and you're kind of distracted, right? You're not really paying attention. And maybe you're at school and the teacher goes, Jonathan, whatever, and they say, what did I just say? And sometimes, even though you weren't listening and you don't really know, you're able to repeat back the last few words that they said, right? Or you're able to repeat back the last thing that they were saying, even though you know you weren't paying attention. That's because of this echoic memory, that it's held on for a few seconds. Now, if that teacher, and so like this is something whenever I do that, I do this on purpose, right? If they say, Jonathan, and then they wait a second or two, and then they ask you, what did I just say? Then information's probably gone. So again, we just hold on to that sound, that auditory information a little bit longer than most other things. We also have what is called haptic memory. Haptic memory has to do with our sense of touch. So when we feel something. Now again, this is going to take a little bit more quicker than sound, but longer than sight, which is about 2 seconds. So those kind of feelings last for about 2 seconds. Again, if we don't pay attention to it, it goes away. Now, if we pay attention, right, if our selective attention pays attention to this information that's coming in, that's in our sensory memory, that information will move into our short-term memory. Sometimes they'll also call this the STM, short-term memory. Now, we're going to talk about the working memory for a second. Now, these are technically 2 different things, but they're talking about the same part of the 3-stage model. They're still talking about the same stage. It's just basically a little bit different ways of looking at it. So our short-term memory is basically our capacity to hold a small amount of information actively in our minds for about 30 seconds. Okay, now this is readily available information. So this is why, for example, I can say, remember the number 52, and then I can keep talking about, the short-term memory. I could talk about how it's about the same length as Snapchat. I could point out this picture in front of you, and then I could say, what number did I ask you to remember? Now, most of you probably remember the number because it's going to sit in your brain. You paid attention to what I said, So it's going to sit in your brain for about 30 seconds. That's this idea of short-term memory. Now, working memory is a little bit different. Some people use these interchangeably. Technically, they're not. It's really what happened was there was the three-stage model, and then Bedeli added in working memory. So he looked at the short-term memory and the three-stage model, and he said, you know, I don't think how they're defining short-term memory is quite right. And so what he did is he kind of changed it a little bit and said, you know, I think more accurately we should call it the working memory. So what the working memory is, or what the difference might be, is that this is an active system of processing information. So it's not necessarily just that this information is coming in and being held in our brain, but it can also be manipulated. And that's really important because obviously when we think about stuff, we don't just think about exactly what someone said, right? We can mess with it a little bit. So within our working memory, there's a whole bunch of different things going on. So for example, we have what's called a phonological loop. A phonological loop is holding on to preserving verbal and auditory information. So what we hear, what somebody says, and we've got this loop that we can kind of repeat it in our head over and over again. We also have what he calls a visuospatial scratch pad that preserves visual data. So when I see something, I can close my eyes and picture it in my head. I can kind of add things in. Same thing where I can hear somebody say something and I can close my eyes and picture it. So for example, if I told you to close your eyes and picture a calm lake with a gentle breeze flowing over and a duck flying over your head, you can picture that, right? That's what's going on in that visual spatial scratch pad. And then lastly, there's also a central manager that is controlling our attention to what he calls data, but basically information. So again, the big difference here is that this working memory is manipulating these things. Now, what the working memory is actually doing is taking our visual data, our verbal data, our attention, and our long-term memory and combining them to create what we call the train of thought, what you are actively thinking about at the moment. Now, what's important is the separation between just short-term memory of, you know, holding a small amount of information in our head for 30 seconds, and working memory, where we are combining visual information, auditory information, information from our long-term memory, so something we remember or learned, or, you know, a skill we have or whatever, taking our attention, and then we are creating this train of thought. Okay, again, the big pieces is that this is what's happening consciously. You aren't necessarily consciously paying attention to our sensory memory. We aren't necessarily consciously paying attention to our long-term memory. We're consciously thinking about and using our short-term memory or our working memory. Now, within that, there are some kind of limitations to short-term memory or the working memory. We've actually already talked about this a little bit. We did an experiment early on. It was the short-term memory test where you had to remember letters. And what that was showing us is an example of what's called a memory span. Now, this can be a little tricky because usually when you think of span, you think of time, right? Like a lifespan. Memory span is referring to an amount of information, not a length of time. So basically what a memory span is the number of items or individual pieces of information, so for example, letters or numbers, that we can remember and repeat back using attention and short-term memory. So again, this idea is you're not able to like write it down, or you're not able to spend, you know, days memorizing something or whatever. It's just what am I able to pay attention to, remember for a short period of time, and then spit back out. So we found the general idea of what we believe the memory span is from a psychologist named George Miller. George basically did pretty much the test that we did, although it was a little bit different. And what it gave us was basically the what we call the magic number 7, which is why we have 7 in a nice little hat here, right? The magic number 7, which is basically that human beings, on average, can hold between 7. It's basically 7 plus or minus 2 unrelated pieces of information. So 7 or somewhere between 5 and 9 random letters, random numbers, random objects, whatever, that we can remember at once. If I start giving you 16 letters at once, all to remember, you can't remember them all. It's just too much information. So again, it's in between 5 and 9. So we say it's 7 plus or minus 2. It's somewhere kind of in that range is where human beings sit. The last piece is, can I get out of the way here somewhere? Okay, cool. The last stage is our long-term memory, or LTM. Long-term memory is the final stage of memory where we can store information indefinitely. Now, this is kind of an important piece, is our long-term memory is limitless. There is no cap to it. Now, the only thing that's going to limit our long-term memory, because you might be saying, well, how can it be limitless? Because I forget stuff all the time, right? The only thing that can put a cap on it is the relative importance of that information. So are we maintaining that information? Is it something we use? Is it something we care about? That's what's going to kind of determine how long we're able to remember it. But there is no limit. So where we can kind of draw a nice separation is if you think about like a computer. At some point with a computer, it fills up. There's only a finite amount of information that a computer can hold, and once you have too much stuff, it fills up. Most of you probably maybe haven't had that problem with a computer, but I'm sure a lot of you have had that problem with your phone, right? If you take too many pictures, eventually it says, no, you can't take any more pictures, it's full. Our brains never do that. We can constantly add information for our entire lives, and we can hold information from, the second we learn it until we die. It's all about what do we do to maintain that information. Now, again, that information must be encoded. It has to go through that process where we actually are taking it and pulling it in and bringing it to our working memory and then moving it in. So it has to go through that process, but once it's gone through there, it can sit there forever. And it really just depends on kind of a lot of things. So kind of an interesting thing that really separates the human mind from like computers where, there is no, at least at this point, we can't live long enough to ever get there, but there is no limit to how much information we can store and how long we can hold on to that information. So that's going to kind of wrap up our conversation on the models of memory. Now, again, I'm just going to kind of really quickly click through everything just so you can kind of separate everything again. So our first model we had was the information processing model. There were the 3 steps of encoding, storage, and retrieval. Within encoding, we have automatic and effortful processing. Within effortful processing, we have explicit memories, which can be broken down into episodic or semantic. Automatic are going to create implicit memories. Then we have storage, we've got retrieval. Our second model was the levels of processing. We can break that down into shallow and deep, although sometimes we will also have what is called intermediate processing. So we got shallow, we got deep, and then lastly we had our 3-stage model, which had the 3 different parts: sensory memory, short-term memory, and long-term memory. So please take a few moments and write a nice short summary, about 4 to 5 sentences, and I will see you guys next time.